Hello everyone, very good morning. I hope everyone is doing fine and well. So today in the class we are supposed to read work energy theorem and after the center of mass and collision. But before we move on to the today's topic, we have some questions left from the previous session. Okay? So first we will do these questions. Okay. Okay, some anonymous participant, I got a message. I will let you know. I'm taking your number over here. Okay, done hai. Once it gets created, I will be definitely getting you added. Okay. Okay. Today I will talk with my team on urgent basis. Don't worry. It will get done. It will get done by today, end of the day. ठीक है चलो so let's start with this question ये questions काफी ज्यादा common है such sort of questions used to come almost every year so read it carefully and try to solve it. I will just give you 1.5 minutes, that is also more, but let's stick to at least this time, this 1.5 minutes. ठीक है चलो your time starts now. Everyone read the question, solve it. Okay, I got so many answers. I mean, six answers I got so far, and two out of that is correct. You can share your answers in the chat section also so that I can tell you if you are getting it right or wrong, so that you can again revise the calculation. Yes, ठीक है. Maleshwari. Yeah, it's correct. Very good. That's great. You have still some 15 seconds left or 20 seconds. No, you have already passed the time actually. So let's end the poll over here and let us do it now together. Okay? Try to see where you are doing mistakes. So what is the question? There is a bullet from a gun and this is fired on a rectangular wooden block. So we have a rectangular wooden block with velocity u. There is a bullet coming from velocity how much? U. And the bullet travels 24 centimeter through the block along its length horizontally. Velocity of bullet becomes u by 3. So what is happening over here? This bullet travels horizontally up to what distance? 24 centimeter. And in this distance, after traveling, what happens? Its speed decreases to u by 3. So here its speed was u and here its speed is u by 3. It is happening in 24 centimeter of distance. Now it further penetrates into the block in the same direction before coming to rest exactly at the other end of the block. Okay, this is okay. This question is from basically energy thing, but I've included it over here. Anyway, you have already done it, so let's क्योंकि आप लोग पढ़ चुके हो, obviously you know all the concepts. So let's solve it now. So this is this. Then it further penetrates into the block in the same direction before coming to rest exactly at the other end of the block. So it is again traveling the rest of the distance, and when it is passing through the block, exiting the block, its speed is becoming 0. Then we have to tell the total length of the block. So what is happening over here? Some sort of resistive force is acting because bullet is traveling through the block. So block is applying that resistive force, and because of that, what? Velocity is decreasing, so kinetic energy is decreasing basically. हमने work energy theorem पढ़ा है. It states that work done by all forces is equal to change in kinetic energy. This is basically topic of today. So I don't know, somewhat mistake happened in placing the question over here, but no worries. So work done by all forces equal to change in kinetic energy. And let's say the force acting, the internal resistance force acting is F. So work done is how much? F into 24. And this is equal to change in kinetic energy. Since this is a resistive force, this work done will be negative because it is resisting the motion. Change in kinetic energy, final minus initial. सो आप क्या लिखोगे? हाफ एम वी स्क्वायर यू बाई 3 का स्क्वायर, सो यू स्क्वायर बाई 9 माइनस हाफ एम यू का स्क्वायर, समथिंग लाइक दैट. डन है. सो माइनस एफ 24 एफ इज इक्वल टू हाउ मच? हाफ एम यू स्क्वायर को आप कॉमन ले लो. So you are getting 1 by 9 minus 1. So this is minus 8 by 9 half mu square. And this is equal to 24f with negative sign. So this will get cancelled. So 24f is equal to how much? 8 by 9 k naught. K naught is what? Initial kinetic energy. Now if you look at the, yeah, I will definitely let her know. I will definitely initiate the thing. I felt like it's happening already. So today I will drop that in the group. Sorry, students, it's regarding, I'm just answering my tech thing. Okay. You don't get confused. So here, what's the thing now? From now its speed is changing from u by 3 to 0. So what is this distance? We need to calculate. Done it? So same thing you do here because resistive force is not going to change. Let's say this distance is x. So work done is minus fx. Okay? This is what? Minus fx. Yes, Punit, you are correct. So minus fx will be equal to how much? Change in kinetic energy. So again, it will be equal to final kinetic energy 0. Initial is half mu square by 9. So fx is equal to how much? This is equal to 1 by 9 k naught. What we have to calculate? X. So k naught का value आप यहाँ से लिख सकते हो ना first equation से. So what is the value of k naught? This is equal to 24f into 9 by 8 into 1 by 9. So 1 by 9 cannot, I have written here. F will get cancelled. 9 will get cancelled. And this will become 3. So x is equal to how much? It is equal to 3. So this additional x is 3. Overall, it was 24. So total length is how much? 24 plus 3. So that is equal to 27. So what you have to use here in such type of questions? Work energy theorem. Work done by all forces is equal to change in kinetic energy. You don't have to worry about what sort of force is acting. Okay? You just have to know कि resistive force is acting. Let's say it's F. Work done you calculate. Change in kinetic energy you write. Accordingly, you will be able to get the answer. So this is how you will solve this question. ठीक है? This is from laws of motion कल के topic से. So I really deviated in the first question, but it's fine. Let's do this question now, everybody. I will launch the poll now. So take your time. 1.5 minute again I'm giving to you. क्योंकि हमें स्पीड को भी प्रैक्टिस करना है, ठीक है? So only 1.5 minutes I'm giving. Okay. Please don't put in random answers because the moment I'm launching the poll, some people are putting in the answer. Please take your time, solve it, then only let me know what you're getting. Okay? It's my kind request. Please. One answer I got, this is not correct. So please write the things and then do it. Yes, everyone doing it? Okay, I got so far 4 answers. Two is correct, two is incorrect. Okay. तुम्हें बस इक्वेशन ऑफ मोशंस लिखने हैं. सो यू हैव टू बी, आई मीन, यू फर्स्ट थिंग यू हैव टू कीप पेशेंस. 2 स्टेप का सोल्यूशन आएगा. 2 equations or 3 equations you need to write. But this question is quite easy. It's not something you should leave. Done hai? It's very easy. And calculation is also easy. That is why I'm telling you. It is looking lengthy, but it's not difficult. So such sort of questions should not be left in the examination hall. Okay, we have already passed the time limit. So let's do it together now. क्या है question? In the diagram shown, normal reaction force between 2 kg and 1 kg is. So what will be the thing? सबसे पहले अगर आप सोचो, in the previous class also I told you about system. So here 3 kg, 2 kg, 1 kg, they are in contact with each other. It means they are moving together, right? So their acceleration will be same. Then in that same case, what I can do, I can replace these 3 bodies with a single body for calculating acceleration. So single body will have mass, then how much? 3 plus 2 plus 1, that is your 6 kg. And on this 6 kg, 18 Newton force is acting in this direction. And in this direction, how much force is acting? 60 Newton force is acting. Okay? So net force, okay, 60 something. You are getting it wrong actually. Need to recheck again. Okay, so if you're looking here carefully, what will be the acceleration? 60 Newton upward, 18 Newton downward. So net force is acting in the upward sense. Net force is how much? 60 minus 18 divided by 6. This will be your acceleration. So 60 minus 18 will be equal to how much? Okay, there will be one more force. देखो तुम लोग करेक्ट किया करो प्लीज. तुम लोग बस देख रहे हो. अभी मैंने नेट फोर्स इतना लिख दिया, बट दिस इज नॉट द नेट फोर्स, राइट? वेयर वी आर मिसिंग, कैन एनीवन टेल मी कहाँ पे मिस्टेक कर रही हूँ मैं? चलो बताओ जल्दी से. विच फोर्स आई लेफ्ट हियर? That is your gravitational force. So that will act in this direction. How much? Mg sine theta. So that is equal to 6g, that is 10, into sine theta, that is half. So this will be equal to how much? 30 Newton. So net force acting in the downward direction is how much? 48 Newton. Net force acting in the upward direction is how much? 60 Newton. So overall net force acting in the upward direction is 60 minus 48 divided by mass will give you acceleration. So this is this. Okay. So this will be equal to how much? 12 by 6. So this is equal to 2 meter per second square. So you already know the acceleration. Now what you have to do? We have to calculate normal reaction force between 2 kg and 1 kg. अगर आप 2 kg और 1 kg को ध्यान से देखो, so let's simply apply the equation, or let's simply write the free body diagram of 1 kg now. So let's now enter into the system and write free body diagram for one of the body, that is here 1 kg. So अगर मैं 1 kg के लिए लिखूं, तो 1 kg पे कौन कौन से forces लग रहे हैं? अब मुझे सही सही बताओ. So 1 kg is this. On this, gravitational force will act downward. How much? 1 into g, that is 10, into sine 30, that is into half. So this will become simply 5 Newton gravitational force. And since 1 kg is in contact with the 2 kg, 1 kg is pressing 2 kg downward. So reaction force of this will act on 1 kg in the upward sense, right? So let's say this force is equal to F. Any other force is acting on 1 kg? Yes, 18 Newton is directly acting on the 1 kg. So this is this, right? अब आप इसको इजीली सॉल्व कर लो. यहाँ पे देखो 1 kg का एक्सेलरेशन क्या है? 2 मीटर पर सेकेंड स्क्वायर, एंड दैट इज इन विच डायरेक्शन? अपवर्ड डायरेक्शन. So here net force has to be in upward direction. So add all the upward forces, that is equal to F. Subtract it with downward forces, that is minus 5 minus 18, and this will give you mass into acceleration, that is equal to 2. ठीक है. So 18 plus 5 will give you 23, and F will become equal to 25 Newton. So correct answer is what? 25 Newton. That is why in yesterday's class I told you the importance of system. System का acceleration निकाल लो, उसके बाद within the system if there is any other question, then pick that particular body, write the free body diagram, write equation, second law of Newton को apply करो, you will get the answer. This question also came in 2023 NEET. ठीक है, so important one. चलो let's do this. चलो जल्दी से करना तुम लोग. This time strictly I am going to give you 1.5 minutes. ठीक है. Question is again easy. It's not difficult. Yes, everyone doing it? मौत का कुआं सुने हो ना? This basically here the diagram will look like that only. ठीक है? So I have taught this thing in classroom also. I have talked about how to write equations in such cases. Okay, I got one answer, but it doesn't look correct. Can you revise your calculation? Maybe there you are doing mistake. Only 15 seconds left. Okay, time is up. Let me end the poll and let's now do it. Okay, chalo, let's do it together now. Okay, Punit. Yes, you are right. That's the correct answer. Okay, so there is a block of mass 10 kg. This is in contact against the inner wall of a hollow cylindrical drum. So there is a drum. This is a hollow cylindrical drum. And this is of radius 1 meter. So this radius is given. This is equal to 1 meter. Coefficient of friction between block and the inner wall of cylinder is 0.1. 0.1. So friction, this wall has a friction. Its coefficient is 0.1. The minimum angular velocity needed for cylinder to keep the block stationary when the cylinder is vertical and rotating about its axis. So this cylinder is rotating about its axis like this. And what is happening here? There is a block kept on its wall. Condition is we have to keep this block in rest. For that, what should be the value of omega? How it will stay in rest? This is a question, right? So just write its FBD, free body diagram. यहाँ पे देखो, it has tendency to slip down. Then, so in downward direction, what sort of forces will act? In downward direction, gravitational force will act and friction will oppose this motion. So friction will act in the upward sense. And if this body is not slipping down, in that case, friction will be equal to mg. Simple question. So mg will be equal to mu normal. Now the question is, what is the normal reaction? So normal reaction किधर लगता है? Perpendicular to the surface. So normal reaction on this body will act in this sense. Then what will be its value? Again, there is one more thing given. This block is kept on a cylindrical wall and that wall is in rotation. So when the cylinder is rotating like this block is also rotating in a circle of radius 1 meter. So centripetal force is acting on it and that force is getting provided here by normal reaction. And so this will be equal to m omega square r. So let's write here the values. Mg will be equal to mu into m omega square r. So m will get cancelled and omega square is equal to g by mu r. So if you put in the values, 10 by mu is 0.1, radius is 1. So this is omega square is basically 100. So omega will be equal to 10. Okay? So correct answer is what? 3. Question is not difficult. You just need to imagine the things and you need to write the equations. Okay? Let's do this last question. I will give for you, for this question, I will give you only 1 minute because this question is quite easy. Okay? Take 1 minute, do it. Your time starts now. You can text me your answers also. Okay, I got one correct answer. Everyone, please come on, vote. I mean, put in your options.
Hi.
Who is here? Yes, done. Okay, time is over. Let me end the poll here. I got 3 correct answers so far and total 7 answers. Now let's look at the thing. Yes, Puneet, that's correct. So this question is from vertical circle. This came in 2020 or something. So there is a mass attached to a thin wire and this is whirled in a vertical circle. So there is this string and this is moving in a vertical circle. The wire is most likely to break when it will have more tendency to break when tension is higher. So you have to check at which point tension will be higher. So at bottommost point, if you write the FBD, mg downward, tension upward, if it is moving, if at this point it has velocity v, then uh, net force acting towards the center is T minus mg, and this is equal to mv square by r. So T at the bottom is equal to mg plus mv square by r. As you will go up, as this string will go up, what will happen? Component of, I mean, not whole mg will act towards the center. Its component will go towards the center. So T will, in that case, T will become mg cos theta plus mv square by r. So as the ball will go up, this mg will keep on decreasing. It means what? Yesterday I have written for the random position. I have written FBD for random position, right? So as you will go up, tension will keep on decreasing. I have also told you for completing the circle, what is the case? I mean, some minimum velocity will provide it at the bottom. And for that, what is the case at the top? Tension becomes 0, right? So as it will go up, tension has tendency to decrease. Done. So tension is maximum at the bottom. So the has tendency to break, not mass, that is string has tendency to break maximum at the bottom. So correct answer will be C. Chalo, let's now move on to work, power, energy and center of mass. Quickly, I will revise the thing. Energy theorem. यहाँ पे बस तुम्हें एक दो थ्योरम याद रखने हैं. First theorem is what? Work done by all forces is equal to change in kinetic energy. The one, I mean, related to this, we did one questions in the beginning, right? So this is the first thing. Second thing is, if there is no dissipative force acting, I mean, only conservative force such as electrostatic force, gravitational force is acting, then mechanical energy is conserved. Mechanical energy is what? That is sum of potential energy plus, sorry, mechanical energy is written as what? Potential energy plus kinetic energy. Okay? So in that case, it will be conserved. In which case, when there is no dissipative force acting. I mean, if there is no friction. Then so this is another thing. And third thing about conservative force is that work done by conservative force is equal to negative of change in potential energy. This thing you also have to remember. यहाँ पे जब मैंने all forces लिखे ना, under this whatever is coming, what is coming? Work done by conservative force, work done by non-conservative force, or any other sort of force. So all forces are considered here. Done है? And that is equal to change in kinetic energy, work done by all forces. But if we talk about only conservative force, in that case, that is equal to negative of change in potential energy. And when there is only conservative force acting, then potential energy plus kinetic energy is equal to constant. Okay? So this is equal to basically constant. This thing you have to remember here. Now, center of mass में क्या क्या चीजें हैं जो आ सकती है, और कोलिजन में क्या क्या है, तो चलो थोड़ा सा रिवाइज कर लेते हैं. सेंटर ऑफ मास थिंग में जब भी whenever body is continuous and geometrically symmetrical, then center of mass will be at its geometrical center. I mean, all these bodies, if all these bodies are uniformly made, it means mass distribution is uniform, and they are symmetrical. I mean, along one line, their mass is symmetrically distributed. In that case, center of mass will be at its geometrical center. So for cylinder, it will be at its geometrical center. For triangular lamina, it will be at its centroid. For circular lamina, it will be at its center, and so on. Okay? So this thing you must be aware of. उसके बाद तीन फॉर्मूलाज है जो हमें याद रखना है. फॉर हाफ रिंग, if this is the ring and you are asked where is its center of mass, so its center of mass is somewhere here. If we are taking this as x-axis, this is y-axis, then its center of mass is somewhere here at a distance 2r by pi. ठीक है? So from here we can conclude one thing, that center of mass can be outside the body. Now next is your half disk. हाफ डिस्क कैसा होगा? इस पूरे बॉडी में मासेस होंगे, एंड वेयर विल बी इट्स सेंटर ऑफ मास. सो लेट्स से दिस इज एक्स एक्सिस and this is y-axis. So again, center of mass will be somewhere here at a distance of 4r by 3 pi. What will be the thing for cone? Cone के लिए क्या होगा? Again, body should have uniform mass distribution. So cone के लिए h by 4 will be the distance from the bottom of center of mass. So cone something looks like this. Okay, so its center of mass will be somewhere here from the bottom, and this distance is how much? H by 4. So from apex, if you are calculating this center of mass, it will be at a distance of 3h by 4, because this whole height is h. Okay, so these three formulas you need to remember. Though questions have, there were no recent questions I couldn't get from this portion, but still this is important. Center of mass with cavity. और अगर यहाँ पे हमने कंटिन्यूअस बॉडी का देखा, एक काम करते, उसको करने से पहले सेंटर ऑफ मास ऑफ डिस्क्रीट बॉडीज का फॉर्मूला पता होगा आप सबको. सो इफ देर आर masses distributed like this, they have x coordinate, y coordinate, z coordinate. So xcm is written as what? We have taken 4 particles here, m1, m2, m3, m4. So you already know how we calculate it. M1, x1, where this particle has x coordinate equal to x1, m2, x2, and so on, divided by m1 plus m2 plus so on, right? So this is how we calculate xcm. YCM, m1, y1 plus m2, y2 dot dot, divided by m1 plus m2 plus m3 plus m4. Similarly, we can calculate ZCM. So for discrete body. For continuous bodies, we use all those differentiation and integration and all. Basically integration done. But these are the 3 continuous bodies formula that you should remember, because exam you're not going to calculate it, right? There is another thing, center of mass with cavity. So if you have a sphere like this of mass m, so its center of mass will be at its geometrical center if mass is uniformly distributed then. And now if somebody is saying you that you are removing this portion of mass, let's say its radius is something small r, and this bigger one has radius capital R. So this portion of mass is getting removed. So let's say the mass of removed portion is just small m. Where will be the center of mass now? So simple है, अगर आप initially देखो, initially center of mass was where? Here. Then at the center, you are removing what? You are removing this portion of the sphere out, right? So this portion has its center of mass at its geometrical center. यहाँ पे था, whole body का यहाँ था, ठीक है. So basically both has center of mass on the x axis. So new center of mass of the whole body will be somewhere on the x axis itself. So formula आप क्या लिखोगे, xcm will be equal to mx1 minus small mx2 divided by m plus m. This is the formula we are going to write. Negative sign here we have given because we are removing it. Done it. So this is how we are going to do such questions. You must have done it before also. So if you want to practice such questions, you can look at the question of JEE Mains. There you will get it more. Okay. In the NEET portion, I didn't get much. अब देखो कोलिजन में तुम्हें क्या क्या याद रखना है. कोलिजन इज बेसिकली व्हेन टू masses are coming together and two bodies are coming together, they are colliding. Then collision can be of basically two kinds, so elastic and inelastic. ठीक है. So whatever is the type of collision, one thing is common in both the collisions. What will be constant? Momentum will be conserved. मोमेंटम क्या होगा तुम्हारा, कंजर्व्ड होगा. सारे ही कोलिजन में मोमेंटम क्या होता है, कंजर्व होता है. लेकिन एनर्जी इज कंजर्व्ड इन विच कोलिजन, इन इलास्टिक कोलिजन एनर्जी इज कंजर्व्ड. ओके, हियर व्हाट इज हैपनिंग, एनर्जी इज कंजर्व्ड. एंड इन इलास्टिक कोलिजन what is energy is not conserved. So here energy is not conserved. Done. So one common equation that we can write for all sort of collision is momentum is conserved. Let's say there is a body of mass A. It's moving in this direction with velocity v1. There is a body of there is a body B of mass something, and it is moving forward with velocity v2. Let's say v2 is less than v1. So what will happen? A will catch B, and if they are moving along the same line, they will collide, right? So they are going to collide. During collision, what will happen? In this direction, force will act, है ना, along their center of mass. Always remember, there is one thing to be kept in mind when you are solving collision. Collision में क्या होता है, इस basic चीज को ध्यान से देख लो. When bodies are coming together, ठीक है, what is happening? They collided. Force will act. Internal force will operate because now they are in contact. So contact force will operate, and that contact force will operate in which direction? Along line of impact. Line of impact हम कैसे बनाते हैं? Just identify center of mass of each bodies. So body A has a center of mass here. Body B has a center of mass here. Combine these two center of masses, and whatever line you are getting, that is your line of impact. So along line of impact, contact force will act, and along this line itself, we will conserve momentum. ठीक है. So along this line, initial momentum, जैसे अगर मैंने इसको सिस्टम मान लिया, इसको सिस्टम मान लिया, so whatever force is acting is internal force because both A and B are constituting a system. So force between A and B is now internal force. ठीक है. So initial momentum क्या लिखोगे? m1 v1 plus m2 v2 along which line? Along the line of impact. Finally, after collision, let's say A started moving with v1 dash and B started moving with v2 dash. ठीक है. So final momentum of the system is how much? It is equal to m1 v1 dash plus m2 v2 dash. And here momentum is conserved because we are considering A and B as a system. So overall system का initial momentum ये है, final ये है, both will be equal. So this is conservation of momentum. एक equation. अगर ये collision elastic है, then you can write another equation that is energy conservation. So initial energy of the system आप क्या लिखोगे? Half m1 v1 square plus half m2 v2 square. And this is equal to half m1 v1 dash का square plus half m2 v2 dash का square. So energy को भी conserve कर दिया. But if the collision is inelastic, you cannot write energy वाला equation. Then you have another option of writing equation, that is by using coefficient of restitution. So coefficient of restitution क्या होता है? This is basically velocity of separation divided by velocity of approach. ये हम कैसे लिखते हैं? ये हमेशा लिखने में बच्चे गलती करते हैं. सो यहाँ पे ये ध्यान रखना है, वेलोसिटी ऑफ सेपरेशन कहने का मतलब कोलिजन के बाद जो जैसे यहाँ पे देखो मैंने इनिशियली क्या बोला, v2 is less than v1. So A is approaching B. With what velocity? V1 minus V2. Velocity of A with respect to V. That will be the velocity of approach. So V1 minus V2. What is happening after collision? During collision on A, force is acting in this sense. And A has a velocity in forward sense. So its velocity will decrease. So V1 dash now is less than V2 dash. It means B is getting separated from A. With what velocity? With what relative velocity? B is getting separated with A. V2 dash minus V1 dash. V2 dash minus V1 dash. So you have to carefully write velocity of separation, that is V2 dash minus V1 dash. Velocity of approach V1 minus V2. And this is equal to coefficient of restitution. If the collision is elastic, coefficient of restitution is 1. If collision is inelastic, coefficient of restitution will be given. If collision is completely inelastic, perfectly inelastic, in that case, E is 0. Perfectly inelastic means after collision, they are not getting separated. They are becoming one body. So this is concept of collision. Okay? Done है? Anyone having any doubt in understanding things? We will do questions quickly. है ना, क्योंकि अगर आप समझ गए हो, क्वेश्चंस won't take much time. डन है. अभी के बाद से I will be giving you strictly 1.5 minutes and you will be solving questions. Anyone has any doubt? Punit, Maleshwari, sorry I couldn't see your answer. Sethi, anyone? Any doubt? Reshmi, Pooja, Nitin, सभी क्लियर है? ओके, डन है, डन है, थैंक यू. लेट्स मूव ahead with the question. चलो, take your time. I am going to start the timer now. So yeah. Yes, Krishna, get it done, solve it. Yeah, just 6 seconds left, 5 seconds. Only one answer I got, and that also is not correct. Okay, here I'm ending the poll now. Okay, 3 answers I got. Out of that, one is correct. Let's now look at the thing. Manisha, it's not correct somehow. Okay, let's look at it. So what is the question? There is an object moving along horizontal x direction. Yes. Punit, not. Let's see. Horizontal x direction with kinetic energy 10 joules. So initial kinetic energy is given. That is how much? That is your 10 joule. And this is displaced through 3 I cap by the force this. So displacement is given. Displacement is how much? 3 I cap. And what is the force acting here? That is minus 2 I cap plus 3 J cap. Done. The kinetic energy of object at the end of displacement. So what will be kinetic energy at the end of displacement? Let's see now. Shruti, it seems incorrect. I don't know why you people are doing mistakes. Question is too easy. You just need to use uh, work energy theorem. Work done by all forces is equal to change in kinetic energy. So here the force acting is F. Work done आप निकाल लो. Work done क्या होता है? F dot ds, right? So F dot delta S अगर आप यहाँ पे करोगे, what you are going to get minus 2 I cap plus 3 J cap dot 3 I cap. So if you're going to do the dot product, I dot I 1, so minus 2 into 3, that is your minus 6 plus 3 j cap dot 3 I cap j cap dot I cap क्या होता है 0, so this is 0. So work done is how much? Minus 6 joule. And this work done will be equal to what? It will be equal to change in kinetic energy. Done it? So now final kinetic energy we have to calculate, right? So let's say final kinetic energy is kf. Initial kinetic energy is how much? That is 10 joule. And this is equal to minus 6. ठीक है? So kf is equal to how much? 4 joule. जिन्होंने भी 16 जूल आंसर किया है ना, they didn't put the sign correctly. So please don't do such mistakes. This will be very harmful for your marks. So this is 4 joule, right? Simple question. This came last year only. चलो अब आप करो इस क्वेश्चन को. इसमें तो कुछ भी नहीं करना. आई एम जस्ट गिविंग यू 1 minute. Okay, your time has already started. Okay, 30 seconds has already passed. Okay, I got one answer. But you need to revisit your calculation. एक बार चेक करो क्या मिस्टेक हो रहा है. एनर्जी कंजर्वेशन से बहुत सारे क्वेश्चंस हैं, so please have a command over it, and it won't take much of your time. Even if you have not done any question before from this person, you can easily crack it now. This is so much easy, very easy in fact. Okay, I got 3 correct answers and overall 7 answers. Time is over now. Yeah, I've already given you 1.5 minutes. So let's now do it. What's the question? An object falls from a height of 10 meter above the ground. So object is at 10 meter of height. Here the object is, right? And after striking the ground, it loses 50% of its kinetic energy. You already must be knowing such things. Just say it is kept at a height of 10 meter at rest. So it has potential energy, gravitational potential energy. How much? mgh. And this will be equal to how much? Mass is your, what is given? No, not given. So let's say mass is m, and this is 10, and this is 10. So 100 m joule is the potential energy. As it will come down, height will decrease, kinetic energy will increase, and when it will be here, whole potential energy will get converted into kinetic energy. So here kinetic energy, the moment it will touch the ground, its kinetic energy will be 100 m joule, right? Now what is happening? It is rebounding again. I mean, it's again rising to certain height. What is given here? I mean, we have to calculate to what height it will rise if 50% of its kinetic energy it has lost. So what will be its kinetic energy when it will start rising up? Just start rising up. 50% of this. So you just write the final kinetic energy. I mean, just before collision with the ground, it has kinetic energy 100 meter, 100 n joule. And just after collision with the ground, its kinetic energy is going to be how much? 50% of this. That is why I'm writing final kinetic energy. So that is 50% of 100 m. So this is equal to how much? 50 by 100 half. So this is your 50 mj. ठीक है, final kinetic energy. And because of this kinetic energy, it will rise to certain height. So let's say it is rising to some height h. Done. So it will keep on rising until what time? Until its velocity will not become zero. It means until its whole kinetic energy will not get converted into potential. So at this point, it will have only potential energy. So mgh, and this will be equal to 50 m. Why? Because that potential energy itself got converted into kinetic. So if you calculate here, G is 10, so it will get cancelled with 0. And H is equal to how much? This is equal to 5 meter. Done? इसको देखो सॉल्व करने की भी जरूरत नहीं थी. 10 मीटर हाइट से गिरा, 50% एनर्जी लूज कर दिया, सो हाफ हाइट तक जाएगा. सिंपल. सो 5 मीटर विल बी द आंसर. डन है. चलो, नाउ लेट्स डू दिस क्वेश्चन. पावर से भी क्वेश्चन आया है. आई डिडंट पुट इन द फॉर्मूला पावर इन रिवीजन, बट लेट मी टेल यू नाउ. पावर को हम क्या लिखते हैं? डॉट प्रोडक्ट ऑफ फोर्स एंड वेलोसिटी. दिस इज पावर. और एनर्जी के टर्म में हम पावर को क्या लिखते हैं? रेट ऑफ वर्क डन. ठीक है. सो दिस इज दिस. और रेट ऑफ चेंज ऑफ एनर्जी. चलो, अगेन आई एम गिविंग यू 1 minute. डू इट. Anyone is having any difficulty in understanding, you can let me know. Okay, I got 3 answers, 1 correct, 2 incorrect. Again, that's great. More answers, please. Okay. Only 10 seconds left. Okay. Okay. 2 seconds, 1 second, and your time is over. 3 correct answers I got. Overall, 9 people answered it. Where are others? कहाँ हो तुम लोग, ये बताओ मुझे. Yes, Punit. That is correct. So power is what? F dot V. What is the force here? Under the influence of force, 5 Newton. What is the velocity given? 2t, displacement is given as 2t minus 1. S is equal to 2t minus 1. So what will be the velocity? ds by dt. Calculate it. So that is 2. And power is what? Angle is not given in the question. It means you have to take angle as equal to 0. So force is how much? Force is 5 Newton. And velocity is 2 into cos 0. Because it is said that under the influence of 5 Newton, body is moving. Nothing mentioned about angle. It means force is acting parallel to the displacement. So here answer will be 10. I just want to take you to certain things. मुझे लगता है एक जगह मैंने फॉर्मूला गलत लिखा है, मेरे दिमाग में तब से चल रहा है. So I just want to see that. Just let me check that. Yes, here. हाँ, यहाँ पे m minus m होगा ना. This thing. कैविटी का क्वेश्चन ऊपर नेगेटिव था, नीचे भी नेगेटिव होगा यार. This is also negative. mx1 minus small mx2 m minus n. This is the formula. Okay. Sorry. I corrected it now क्योंकि बहुत लोग क्लास लीव कर दोगे तो फिर बाद में तुम गलत फॉर्मूला कैरी करोगे. Okay. Sorry, I broke the flow of class. Let's do it now. चलो, इस क्वेश्चन को करो सभी लोग फास्ट. Take your time. I have launched the poll. Your time is started now. Again, same as before. Nothing much you have to do. Just read the question carefully, apply things one by one. This is a question which should take less than 1 minute. So I will give you only 1 minute, not more than that. So more 15 seconds left. Okay, I got one answer, but it looks incorrect. Okay, 3 answers, 4 answers, but no correct answers. No. Okay, I'm ending the poll now. I only got 7 answers with no correct answer. क्या हुआ यार? करना चाहिए था. Water falls from a height of 60 meter. This is a turbine question, okay? So water is falling from a height of what? Sarath? Yes, that is correct. Punit? Yeah, near about that. Correct. So water is falling from certain height. From what height it is falling down? 60 meter के height से गिर रहा है. And how much mass of water is falling per second? 15 kg mass per second. The loss due to frictional forces, and while it is falling down, air frictions are acting, and because of that, I mean, when the whole the mass is here at 60-meter height, its energy is how much? 60 into mass. So let's say 1 second की मैं बात कर रही हूँ तो 15 kg into 10. So this is the energy, potential energy. As it is falling down, friction force is also acting. Yes, Maleshwari, correct है. So that friction force is reducing its energy और उस energy को खा जा रहा है. How much? 10%. So 10% of this energy आप निकाल लो. 9,000. That is 9 kilowatt. So 10 by 100 into 9, and this is equal to 0.9 kilowatt. This much energy is getting eaten by frictional forces. Now, when the 15 kg water in 1 second will reach to the ground, how much energy it will contain? It will contain, here it had energy 9 kilowatt. 0.9 kilowatt got eaten by air friction. How much energy is left? So energy hitting the ground is how much? 9 minus 0.9. So kilowatt. So that is equal to 8.1, sorry, joule. ठीक है, 8.1 joule. And this energy is coming in how much time? 1 second में. So basically this much joule is coming in 1 second. So this is also power, 8.1 kilowatt. Sorry, this was kilojoule. ठीक है, so answer will be what? 8.1. Yes, Shruti, correct. So this will be the correct answer. बस energy conservation करते जाना है, कुछ नहीं extra करना तुम्हें. Now do this. We can still do 2 questions, है ना? चलो fast करते. Take your 1 minute, do it. Because again, this is a very easy question. Take your 1 minute, do it. Not even 1 minute. This is a 30-second question. Everyone fast. One answer I received, but that's not correct. Check it once. देखो, basic things should be clear. This is a very basic questions, I must say. Okay, I'm ending the poll because one correct answer I got. क्योंकि इसमें कुछ solve करना ही नहीं है. See here, two particles A and B. There are two particles. Let's say this is A, this is B. And I'm taking A and B as a system. So मैंने इन दोनों को क्या consider कर लिया? एक system consider किया. Now what is happening? Yes, Punit. Sarath, no. You need to check. So this is a system, okay? Now they are initially at rest. Now what is happening? Because of mutual force of attraction, what is happening? They start moving towards each other. Then at an instance when the speed of A is V, speed of B is 3V. What is the speed of center of mass? First, let me tell you one thing. Center of mass का speed कब change करेगा? When its momentum will change, when external force will act. I have taken here A and B as a system. So whatever force is acting between A and B is internal force, it's not external force. Done. And if there is no external force acting, सेंटर ऑफ मास का पोजीशन चेंज नहीं होगा, सेंटर ऑफ मास का वेलोसिटी चेंज नहीं होगा, सेंटर ऑफ मास का एक्सेलरेशन चेंज नहीं होगा, आई मीन एक्सेलरेशन आएगा ही नहीं. डन है. सो यहाँ पे इनिशियली द सिस्टम इज एट रेस्ट, फाइनली ऑल्सो सिस्टम विल बी इन रेस्ट बिकॉज नो एक्सटर्नल फोर्स इज एक्टिंग. These two bodies inside the system start moving because of internal forces acting. So initial system का speed 0 है, final भी क्या होगा 0. Correct option will be B. No need to calculate. Do it now. Yes. I'm giving you 1.5 minutes for this. Do it. But if not difficult question, but still I'm giving. Okay. One wrong answer I received. Maya, you're in the class. क्या हुआ आज बहुत चुप बैठी हूँ. Everything all right? Everyone should keep their energies high. है ना? We cannot afford low energy, especially at the time of exams. जो होगा वो होगा. सबसे पहले ना तुम्हारा हेल्थ बहुत इंपॉर्टेंट है. यू हैव टू बी पॉजिटिव. जितना पढ़े हो जितना किए हो उसको प्रैक्टिस करो. ठीक है. सो या I got 4 correct answers out of 8. So 50% accuracy. That is great. देखो इस क्वेश्चन के थ्रू आई विल गिव यू सम वेरी इंपॉर्टेंट इन्फॉर्मेशन. ठीक है. ऐसे तो हम लोग कर डालते हैं क्वेश्चन को, बट यहाँ से कॉन्सेप्ट वाइज करना बहुत जरूरी है. 1 kg particle strikes a wall with a velocity of this. So let's draw the wall at an angle of 60 degree. This thing is falling, striking the wall, and its motion direction is making 60-degree angle with the wall. Here this ball will hit, and then it is recoiling, I mean bouncing back with the same angle, right? It's given, the angle is same. Let's draw here the, let's not do anything as of now. If it remains in contact with wall for 0.1 second, then the force is. ठीक है. सो बेसिक फॉर्मूला जो हमें यूज करना है वो ये यूज करना है. फोर्स क्या होता है तुम्हारा, dp by dt. डन. सो चेंज इन मोमेंटम इज इक्वल टू व्हाट, f dt. हमें यही फॉर्मूला लगाना है. डन है. सो दिस इज द थिंग वी आर गोइंग टू अप्लाई. यस, सेट t करेक्ट. नाउ द थिंग इज चेंज इन मोमेंटम हम किस डायरेक्शन में लेंगे, विच डायरेक्शन वी आर गोइंग टू कंसीडर. जस्ट नाउ आई हैव टोल्ड यू इन द डिस्कशन, momentum change we have to take along the line of impact. So first draw the line of impact. Collision is happening between wall and the ball. So line of impact will pass through the center of mass of the ball. So it will pass something like this, perpendicular to the wall. So this is the line of impact. So along line of impact, we will do momentum conservation. And whatever line is perpendicular to the line of impact, this is this line along the wall. Along this line, velocity of body will remain same. हमेशा याद रखना ये इस लाइन के along velocity क्या रहेगा, same. And इस लाइन के along, that is LOI, along that line you will conserve momentum. So if initially it has a velocity of 1 meter per second, its velocity component along the y direction is how much, 1 into cos 60. And after collision, velocity of the ball along the y direction is how much. I mean direction change दिख रहा है. No, direction भी change नहीं होगा. जैसे देखो initially ball का velocity along y direction is in this sense, and finally the velocity of ball in the y direction is again in this sense. What will be its magnitude? Let's say its velocity is v, so its magnitude will be v cos 60. These two has to be equal, right? इन दोनों को इक्वल होना है. So cos 60 got cancelled. V is 1 meter per second. यानी कि फाइनल वेलोसिटी भी 1 मीटर पर सेकेंड है. नाउ कैलकुलेट मोमेंटम चेंज. सो इनिशियल मोमेंटम अलोंग दिस डायरेक्शन इज हाउ मच? mv sin 60. So that is equal to 1 into 1 into root 3 by 2. This is the initial momentum. What is the final momentum? Final momentum is in this. It will be in this direction. How much? 1 into v into root 3 by 2 with negative sign. So this is equal to how much? 2v root 3 by 2. That is v root 3. V is 1. So this is 1 root 3. Change in momentum you have already got 1 root 3. And this is force. Time is 0.1 second. So force is 10 root 3. So this is your answer. Sorry, I have taken more time. I should leave the class now. Thank you so much, everyone. In the tomorrow's class, we will do rest questions. Bye, everyone. Take care of yourself. I've already exceeded the time, so I need to leave it quickly.